Welcome, everyone.
Welcome, everybody.
Hey, everybody. Welcome to Master Books Facebook Live. Today we are talking about biology through a microscope, and we're all sitting here nice and cozy because we've also invited
You've invented Chris.
Chris
Congratulations, you're
into the meeting. So, and I'm here with Brittany, and how are you doing, Britt?
I'm doing good. How are you?
I'm good. How are you doing, Chris?
Unfortunately here.
Chris is
We'll make the best of it.
Chris is our CIO, right?
That would be the official job title.
Chief Intelligence Officer.
We invented a chief intelligence officer.
And he was involved in developing biology through a microscope. He is the resident genius here at Master Books. And one of the, we actually went out and purchased a high-powered microscope with a camera on it. And so we'll talk about the real-world homeschooling, right? When you buy a biology curriculum and you buy a $300 microscope, sometimes, number one, do you need a $300 microscope for the course? And number two, even if you have a $300 microscope, Chris is a wonderful invention.
Hi, Anna.
Mhm.
Even if you have the $300 microscope, do you understand how to use it, and are you able to get the images that are going to be worth something? So in order to help solve that problem, what we did was came up with biology through a microscope. So what I'm going to have Chris do, now Chris, what was the microscope that we purchased?
We purchased an AM scope, and it's a essentially a trinocular lab microscope. It has a typical binocular head. You can see two images at once, or two eyes at once. You can see in stereo, but also has a camera attachment on the top that you can basically set up all your focusing and then switch over to the camera view and take a picture of exactly what you were seeing through the microscope.
Okay. And then, so what was the camera that you take a picture of?
Camera is an 18 megapixel. It's a custom camera module specifically for the microscope.
Okay. And then the lighting, what's special about this? Had like special lighting, right?
The microscope that we're using has an AB condenser on the bottom. There's a couple different condensers. AB and Kohler illumination are used to set up even lighting under the specimen, and also using special attachments for phase contrast, where it diffracts light differently throughout the diffracts light differently at different angles, so that, especially with semi-transparent organisms that you can't clearly see the edges of, the light highlights those. And that's something that you typically cannot see through an off-the-shelf microscope that you have as a homeschooler. That's reserved for a microscope with a phase contrast head and phase contrast optics.
So I need a translator to speak the foreign language that Chris just gave us. But essentially, that's all described in some of the basics of a microscope are described in the beginning of the book.
Correct.
So what I'm going to have Chris do is we're going to switch to the other camera. I'm going to have him do kind of a walkthrough of the way the book is set up, what's in the book, and then we're going to talk a little bit about how it relates to the masterclass biology and provide some tips for that as well. And Brittany, we're giving away 2,500 reward points. That's $2,500 of purchasing power at masterbooks.com. And today we're going to do that again through a rock, paper, scissors battle. So be ready, because we're going to do that after Chris does the walkthrough. Okay, so we'll switch over and have Chris kind of give us a tutorial on the way the book is set up.
Also, good morning to everybody jumping in on the comments. Okay.
Somebody's hiding. Desiree, no.
That's because Anna can't hear over her kids, and let's see. That's why Desiree is hiding in her room.
Ah.
Okay.
The new slogan for Master Books, hiding in the room. Okay.
There we go.
All right, so I'm going to turn the microphone just a little bit here so that you can still hear me clearly. The way we're set up here is pretty straightforward. Table of contents. The way the book is set up is because this came out after we published the teacher's guide. There's an index in the front where the majority of the information is, and at the very back of there's a table of contents at the front, and at the very back we have a supplementary index that cross-references most of the items that are called out as slides in the student book and teacher's guide. So when you're looking through this, the book is set up to initially look at the table of contents and then reference the index for anything that's not covered in the table of contents. Working through the book, you have a brief overview about a microscope, also a detailed image of the parts of a microscope, some of the different ways that a microscope is used, as well as a example of here what a typical microscope looks like that you would have off the shelf, and then what those same images or that same slide looks like when viewed through phase contrast or dark field, which are two different modes of using microscope, with obscuring the light source from direct observation or using diffraction fields. Down here, we also dig into what a marine diatom, which is a example of a organism with a translucent shell, looks like normally, and then a highlight for phase contrast. After that, the book's broken out into 4 sections. We talk about animals, plants and fungi, insects, and microorganisms. And in each of those sections, we have a general overview of their biology, and then each organism, we dig into certain aspects of them. So, for instance, we use the dog as a case example to pull out images of the tongue, the trachea, the stomach lining up at the top, and also the various portions of the intestine down below. Same thing, flatworms. We did both a cross-section and then a top-down view, as well as views of the eggs. This continues throughout the whole book. And then on some cases, say for example, Lab 18 in the teacher's guide, we go in and actually explore a little bit more clearly how life cycles work. And Randy and I were looking through this morning. When we say in the curriculum that you should look at a slide for the moss life cycle, for instance, or fern life cycle, as this page is. The slides don't really come labeled with what part of the life cycle they are. There may be multiple elements on each slide. So what we tried to do with this book is split them out and label each section with a high-resolution image of what specifically you were looking at. Especially for a homeschool teacher, you may not be aware of exactly what you're looking for on the slides, especially because your child is the one doing the schoolwork, not you. So for the parents who don't have a degree in biology, this is intended to help them by illustrating a little bit more clearly what the child is looking for in the microscope. I'll pull up one other one here that I don't have tagged. For instance, here, where we have Lily of the Lilium family, we actually label the image clearly here. So you see half of it is what you would see, and then over here you have all the different parts labeled specifically with arrows pointed to them. We also try to do that with pine, where you're looking for a pine stem. We break it out into each individual portion so that you can see how this relates to the words. You can visually see how this relates to the words in the book. Same over here for a cross-section of a pine needle. Any questions from the...
Oh, Sarah Bates just asked, what age group is this book geared for? Sarah, it's going to be geared for 9th through 12th grade.
Yeah, designed for high school, but I would imagine even in for any biology course, student could use this book, and just if it references something, you can look at the index in the back, look it up, and find some additional supplement.
One other thing on that is it's geared toward a 9th through 12th grade level, but the text is written to be understandable by a 6th to an 8th grade level, and the images are also interpretable by someone at that level.
Okay.
So there's a little bit of if you have an advanced student who's interested in biology and wants to get a leg up on it before high school, the book would function as an introduction there.
Okay.
Cool.
So before we get into talking about how it interfaces with the biology course, would you like to do, who are we going to give 2,500 reward points to?
All right, so we're going to play rock, paper, scissors.
Do a warm-up first.
Okay, warm up. This one doesn't count, so don't let me know what you did. But ready? We're going to do rock, paper, scissors. Ready? Rock, paper, scissors, shoot. I cut your head. Okay, now for the real deal. You had some warm up. Let us know. We're going to play, then let us know what you got. And if you beat me, I will choose one of the winners to win the reward points. But don't lie. Because
Honor system.
I won't know exactly. Okay, ready? I need to be in the camera. Ready? Rock, paper, scissors, shoot. Rock. So if you got paper, you beat me.
Yeah.
Let me know.
Or dynamite.
Or dynamite. That too wasn't really an option, but if you did dynamite, let me know and you won.
All right, we'll choose somebody here before we get done. So the biology course came out this year, and in each of these, throughout the book, there are lab experiments, and there will be microscope experiments. So some of the images, the high-res images from the experiments, are actually going to appear in this book. And then the ones that aren't in this book, you'll find in this book. So if you don't have a microscope, the image is probably clearer than a lot of people would be able to obtain with your standard off-the-shelf high school microscope.
Correct. Are
going to be higher res and clearer, because you actually spent a lot of time trying to get clear images on this. So it's in the images are between these two books. Now, as we were looking through it, Chris and I were looking through it, and we were matching it up. We could see that it would be easy to confuse a little bit in the labs of kind of where the images are found. So Chris has agreed to help. We're going to create kind of an appendix that we will put up on the website, and we'll put it in the files here as well, that if you're going through and doing the labs, it'll kind of say, if you're looking for, say, an onion tip, it's an onion tip root, right? You're going to be able to find the image on page such and such in this book. If you're looking for something else, paramecium or whatever.
Anything else.
I have no idea what I'm talking about as far as names go. You're going to find it on page such and such of this book. So for each of the labs, we'll kind of give a reference sheet of a cross-reference sheet of this is what page you should look at for this and what page you should look at for this. The other thing I'll say, that just so you know, when you're going through this book, so what we wanted was a supplement that matched the biology, right? And we wanted it also to be where somebody could buy it and see it as a standalone. So otherwise, what you would have is you would just have pages of slide pictures. There'd be no descriptions, no labels, just slide descriptions. So what Chris did is he went through and actually highlighted, like, here's the slide, here's some detail. He breaks it out. There's more information. So the information in here is supplemental. It goes deeper than what you would find in the biology book in some cases. But you're going to find not all the images from the labs are in this book. Some of the images are in the student book already, where it already shows like the stages or that type of thing. So one of the experiments that we were looking at was at lesson 18, right? Lesson 18 is talking about, or laboratory 18, diverse products of protein translation at different stages of development. And so that's one. If we could switch over to the 2 with a 1. Okay, there we go. Okay, so in this, as you go through the experiment, and there's in the introduction to the lab, it talks about ferns and mosses, and then it goes through and says, in the procedure, examine the fern life cycle prepared under the slide, and that's where, if you went then to this picture on, it's that one page, right, with the fern life cycle,
Mm-hmm.
you're going to be able to see kind of where Chris exploded out the different components of this, and at a much higher res image and much more detailed. So what I would say, okay, now we can flip back through. What I would say is, when you look at the biology through the lab, what you're looking at is the image. You're not necessarily looking at the instruction or the additional call-outs. You're looking more at, oh, this is what I would see in the microscope, and then go back to the lab portion. Does that make sense? Did that make sense?
Mm-hmm.
So, did that make sense to you?
Mm-hmm.
Okay. We have a consensus. It made sense.
affirmations.
I
Okay.
feel affirmed right now. So it's what this does is it does give the image, it gives some additional information, but what you're looking for when you use this is, where's the slide image that I would see if I was using this in my own microscope, because it's going to be a better image, and would help you to not have to purchase a microscope. So all the images are available either in the textbook or in this, that you could get away without using a microscope. I mean, optimally a microscope, learning how to use it, the hands-on component of that is worth a lot. But I know for some families, a decent microscope to actually be able to see it is going to cost quite a bit. I think something else that a family could do is, even if you bought a microscope, using this book as a cross-check
Mm-hmm.
is something that would be valuable. So I could have this and just kind of see, what am I looking for in the slide? Because you mentioned like the bacteria versus
The medium that they're growing on some of the slides is actually, if you don't know what you're looking for at the outset, it's very easy to get confused about what you're looking at through the microscope and end up spending time studying the wrong thing.
So this would give you a good kind of a cross-reference of,
Mhm.
okay, when I look at this, this is what I should be looking for, because it should match what you see in the book.
Correct.
So I think it could be useful as a tool that way. Okay, did anybody post, Brett? Any rock, paper,
We
scissors?
had like 4 or 5 papers and a
We
kid's paper
did.
as
I
well.
know. I'm gonna go with Andrea Martin McIver. She said my son did it with me. If that counts, he got paper. I said that counts.
That counts. Okay.
Boom.
So, Andrea, we will make sure we have 2,500 reward points added to your account, and we'll let you know when that happens. If there are any other questions on this course?
Carrie said, Chris, you really did an amazing job on this project. I can't tell you how much we homeschool moms appreciate all of your work.
Yay! Glad it helped.
Yeah. Sometimes it's just hard to get these prepared slides, and you put them on, and then you're trying to determine what you're looking at.
I cannot attest to that personally at all.
Because he did that. And the challenge of getting the images to be clear and all of that was tough.
Time consuming.
Yeah. So good. Well, hopefully that's a little bit of a help as far as how the book works and how it coordinates. As soon as we have the appendix built, we'll be sure to upload it, and I think it'll make it a little bit easier. But in the meantime, I know some of you that are doing the course, the biology course, and you're going to get this. When you come to something and it says, look up a paramecium, go to the back, and
And that's one of the 2 that aren't in there.
okay,
Table of contents first.
because it's in the other. So, okay. But in the organisms and
Genus.
right, genus family,
Can you switch to 2?
yeah,
So
switch
right here.
So that's the page that you would go to, like,
Anything that's not in the table of contents, that's where you would reference.
right, and then you would go to. So let's go to page 52. Chlamydomonas. This is why I don't teach biology to my kids. Okay, so what you would be looking for then, that's what the image would look like under the microscope.
And that is actually, that one specifically is tagged with SEM because that one was taken with a scanning electron microscope, because those are too small to actually even see with an optical microscope.
So even if somebody bought a microscope, they wouldn't even
They'd never be able to see that. That particular one would need to be multiplied something like 15 to 20,000 times.
Okay. Okay.
So there are a few images in there that we didn't buy a scanning electron microscope either, but we were able to source images for a few of those, especially for the very small organisms. We also did that with bacteria as well.
Maybe.
Here.
And so by reading the text, they would get some of the more
They get an
detail.
overview of some of that as well.
Okay. Okay. So as in a first generation course like this, as we receive feedback, we appreciate the feedback that we get from people. I know we're already beginning to look at ways to make it easier to use. If there's any friction points or roadblocks that come up, we want to make sure that we take note of that and address it in future printings. So be sure to let us know if that happens. Chris needs to say that word. What is it?
Chlamydomonas.
Chlamydomonas.
Chlamydomonas. There you go, Carity. I said
This has
it.
been Spanish lessons with Chris.
That's probably Latin.
Most likely.
Latin lessons with
There you
Chris. Join us next week as we learn how to say.
I will be deathly ill next week on Tuesday, obviously.
Well, this video is brought to you by the letter B of biology.
Not for Brittany. I was like, yeah.
All right, guys. Okay, well, hopefully this was helpful. A little explanation, a little bit of a sneak peek on the inside. Any questions, be sure to post.
Constructive feedback also welcome.
Yep, we definitely welcome constructive feedback as well. So, all right, guys, we'll have a fantastic rest of your week. Hope to see you on Thursday for teaching tips, and we will talk to you soon. Bye-bye.
Bye.